All right, today we're looking at this word here, matrix. Somebody tell me what you know about the word matrix. It's a movie. What's the movie about?
Slow motion.
Slow motion. The Matrix. What in the movie The Matrix? What is the actual Matrix? Does anybody remember?
Lots of numbers. A computer program.
It's the computer program. It's the numbers. In the movie, there's a computer screen they're looking at a lot, and it's just got numbers going all over the place. Okay. Now, Matrix it's a box of numbers. So that everybody's kind of on the same boat. We also have this word here, matrices, and that's the plural of matrix. Okay. So one matrix, two or more matrices. So just so you're kind of aware, let you see it. And it's numbers. Numbers organized into rectangular arrays. Finish out the word. Within brackets. What we're doing today is introducing you to what matrices are, how to label them, how to find pieces within them, and making sure you understand like the number of rows and columns, what they are, how to figure that out, and how to name them. It's not going to be difficult today, but it's going to look a little weird. For some of you, if you're taking the ACT in April, matrices are usually on the ACT, and so I wanted to make sure we hit that. Even though I don't really think this is an Algebra 2 skill, it's actually I think an Algebra 3 skill. But it's not difficult, and so we're going to kind of introduce it real quick. After today, so starting on Friday, I kind of show you a few things to do with the calculator with them. So a lot of the operations we do, you'll use calculators, but today there's not a need for that. So real quick, just as a refresher, most of you are doing pretty good. I've got about 4 or 5 of you that are either focusing on some other work or a phone, so make sure you're kind of paying attention, you understand. So you're losing your agency points if you're not paying attention, but you're also losing the knowledge that you're hearing and won't be able to do the work tomorrow. So, first off, here's an example of a matrix. Yeah, you won't have an assignment today, but you will have an assignment tomorrow. If I have okay, I'm hoping that you've already seen matrices before. Some people haven't, but there's an example of one. Okay. It's a rectangular grouping of numbers, and there's brackets on the outside. Okay. Most of the time, matrices will be named with a capital letter. Okay, matrices are almost always named with a capital letter. So we'll call this one matrix A. And then we describe a matrix with its dimensions. Okay. What does the word dimensions mean? Okay, dimensions is its size. Okay, the dimensions of this room, you talk about the length, the width, and the height. Okay. We deal with area like we do with dimensions. But in dimensions of a matrix, use the number of columns, the number of rows, and number of columns. it was introduced in CPAD and CPAD. Okay. Now, if the dimensions use the number of rows and number of columns, how many rows does this matrix have? All right, so the number of rows, there's one row, there's two rows. So the number of rows is 2. And so in this matrix, there's only 2 rows. Okay? So just so we're kind of on the same page again, when we start talking about them, that would be row 1, that would be row 2. Okay, with an R1 and R2. I think a lot of times you may see this with a little r, but same process. Okay. Number of columns. Number of columns. There's 1 column, 2 columns, and 3 columns. So the number of columns in this matrix is 3. And so if I am referring to this matrix, you always put the name of the matrix A, and then underneath it, kind of as a subscript, you hit the number of rows times the number of columns. You don't actually times it, you just put the little X there. And so this matrix is a 2 by 3 matrix. And so it's matrix A and it's 2 by 3. And so that's how you would label this matrix. Okay. Okay. So if it asks you to find the dimensions of a matrix, the 2 by 3 is what we're looking for. Okay, make sure you put the rows first. So a 3 by 2 is not the same thing as a 2 by 3. All right. Questions on that? Here we go. Let's do another one. Okay, so y'all tell me the dimensions of that matrix. Hey y'all, that's the columns. There's only 1 column. But there's 1, 2, 3 rows. So the dimensions are 3 by 1. Okay. Does that make sense? Okay, what if you have this matrix? That would be a 1 by 1 matrix. Okay. Just so you're aware, there aren't many uses for actually making a matrix if it's just a 1 by 1. You just do it that one piece of data at that point. All right, so what's the dimensions of this one real quick? Yeah, 3 rows, 4 columns, so 3 by 4. Okay. 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 The next piece that we need to know about is called a matrix element. And all we're looking at in this part is each piece of data, each number in the matrix is an element in that matrix. Okay, what we're going to do is kind of identify which matrix or which element we're talking about, and I'll kind of show you what we're dealing with on that. So, just, if you want to write that down, you can. Then we're going to go back up to the other examples. Okay, so we're going to start out with this one, and we're going to tell me the number of, the dimensions, and then I'm going to ask you to find different elements. We'll talk about that in a second. So look at those, and you need to write down the, we're going to do a little bit more with the matrix, so I'll probably write down these three. Leave some space out to the side of it so we can talk about them. These are three different matrices, so there's three different dimensions here. All right, so real quickly, the dimensions, this is one row by 3 columns. This one is 2 rows by 3 columns. And this one is 3 rows by 3 columns. Yeah, that wasn't meant to be that way, but it works. Okay, so here's what I want to ask you about. If the directions say find the element of the matrix, and the first element says this here, I'm trying to get it the way it's written in here so that if it says element G23, can anybody think about what that might refer to? Yeah. Okay. The G is going to refer to matrix G. Okay. The 2 and the 3, if I'm trying to find the element, I'm going to find the number that's in row 2, column 3. Okay. So this tells me I'm going to go to matrix G. Remember, that's row 1, row 2. That's where I'm going, and then column 1, column 2, column 3. So row 2, column 3 is -6. Okay, so all we're doing with this piece is we're identifying where these elements are. Okay, and we always talk about matrices dealing with rows and columns. So when it says find the element in G23, that's matrix G, row 2, column 3. I didn't, sorry, it's a little bit lower than it should be. I didn't put the row 3 down there. I was trying to write down there. Perfect. So G23 means I'm going to go to matrix G, row 2, column 3. Okay? So this says matrix G. That says row 2. That says column 3. Okay, and so that's when we talk about the location of the elements, we're dealing with rows and columns. That's how we name it. All right. So call that one number 1. Number 2, let's find what element can be found in S12?
4.
Okay, row 1 in matrix F. So row 1 is here, column 2 is here, negative 1 is main. Okay. So start with which row it's in, find that row, and then go over to that number column.
Number 3.
All right, let's do another one here. Okay, what element is in E11? Matrix E, column 1, row 1, column 1. So negative 3.
Yellow.
All right. Questions over this part? Everybody can do this okay? All right. So this, again, y'all, this is just the intro to it. Okay? The next little piece of it, let me show you one more piece real quick. Okay. Let's introduce this next piece of it. This will be all right. All right. If I've got these two matrices, what are the dimensions of these matrices? 2 by 3s, right? 2 rows, 3 columns.
Yes, sir.
Okay. So, since they are the same, we can do a couple of operations with them. The operations we can do with them are adding and subtracting. If the dimensions are the same, you can always add or subtract the matrices. So, if I want to add matrix A plus matrix B, the way you add or subtract is you add or subtract the corresponding elements. Okay? So my solution matrix is also going to be a 2 by 3 matrix. And in this first spot, that's row 1, column 1, I'm going to add row 1, column 1 plus row 1, column 1. 2 plus 1 and get 3. Okay? In row 1, column 2, I'm going to add row 1, column 2 plus row 1, column 2 and get 8. Okay? For row 1, column 3, row 1, column 3 plus row 1, column 3 and I'll get 7. Okay? What's going to go in that space there? 4 plus 2 is 6. Okay? This place here is also going to be 6. And this spot there is going to be a 4. Okay? Questions on addition? All you do with addition or subtraction is you add the corresponding elements. Okay, so the ones that are in the same position. Even if there are negative numbers in there, you would still add them if there's a plus sign. So if it's negative 2 plus 3, you type in your calculator, negative 2 plus 3. Okay, I didn't put any negatives up there, but that is what you would do. If it said A minus B, you would have the exact same thing, except for instead of 3, it'd be 2 minus 1, which would be 1. Instead of A, it'd be 3 minus 5, which would be negative 2. Okay. So A minus B in this case, 2 minus 1 would be 1. 3 minus 5 would be negative 2. 1 minus 6 would be negative 5. Okay, so that process is the same. You're just subtracting and adding each individual element. Okay. 4 minus 2 is 2. 5 minus 1 is 4. And 0 minus 4 is negative 1. Now, before we finish up, just so you're kind of hearing kind of where we're headed. Multiplication is not the same way. You can't just multiply individual pieces. Okay, there's a whole different piece to that. We'll talk about that on Friday. On division, there's not really any kind of division that you do. We'll talk about what to do with that also. But multiplication is the other thing. There's another piece that we call scalar multiplication, which just means you multiply the entire matrix by a single number. And to do that, you just do just like we did. You multiply, like if it was 3 times A. If I had 3 times A, I just multiply 3 times everything in matrix A. Okay, that'd be my new matrix. And so we'll talk about that on Friday also. You multiply, yeah, everything in matrix A, you multiply 3. If it said 3A. So we'll come back to that on Friday, but that's kind of where we're headed.